Right, we're going to go ahead and get started here. Welcome to today's webinar. Thanks for joining. Today we're going to talk about creating product videos in Creo Parametric. Before we dive into the agenda here, I'm going to start with a real quick poll. First of all, I just want to make sure that everyone can hear me okay. So if you can hear me, just choose yes. If you cannot, okay. So the voting is in. We'll close that. And it looks like for the most part, everybody can hear me. A couple of people maybe cannot. So I'm not sure why that is. You may want to just double check your volume, make sure that you don't have your speakers muted or anything like that. Let me go ahead and hide that. So like I said, today we are going to focus on creating product videos in Creo Parametric. I'm going to start with a quick introduction to myself and to boundary systems, and then I'm going to dive into the demonstration. And we're going to talk about a couple of different tools in Creo that you can use to create videos. We'll talk about mechanism design extension and design animation, and we will also talk about how you can render those videos to make them look more realistic. And right now, everybody is muted, but at the end, I'll open it up for a question and answer. So if you do have questions, there is a question panel in the webinar interface that you can type those into, and then we'll come back and address those at the end. Also, if you have any questions, there is a button to raise your hand if you need to get my attention for something. Like I said, my name is Wade Moravec. I'm the Director of Global Services for Boundary Systems. I've been working with PTC products for just over 20 years. Started out doing pro engineer training in the late 90s and did that for several years primarily. Over the last 10, 15 years, I've gotten more involved in wind chill side of things as well, consulting, implementation, sort of the whole gamut. Boundary Systems is the PTC reseller headquartered out of Cleveland, Ohio. We cover primarily the Midwest, Ohio, and the neighboring states, but we also do go beyond that region in some cases. Our capabilities are focused around CAD design and consulting, product lifecycle management and data management, as well as simulation and product development. So we have a heavy focus on PTC products, but we also have some additional partners that cover some additional areas. Our focus is to have as much technical expertise as possible on all of the products that we support, so that when we work with you, we can do it in a consultative manner where you can sort of explain to us the problems that you're trying to solve and what your goals are, and we can come up with a solution that fits that, whether it's specific software that would help, or additional training or consulting on how to use the software that you already own, so that we're not trying to solve problems that aren't there just to fit them in with our solutions. We want to know what you're trying to accomplish, and we can work with you to meet those goals. Here's just a quick look at some awards and accreditations that we have. We are a certified wind chill implementer, as well as a PTC certified training partner. We do a lot of training in Cleveland, Cincinnati, Pittsburgh, Detroit, Chicago, and then also a few additional locations. If you're looking for any training classes, our full schedule is up on our website, boundarysys.com. And as I mentioned, PTC is sort of our major focus, but then we also have additional partners that cover sort of other areas. Just a couple of these. X Formation has a product called License Statistics. So if you're not sure whether you're really fully utilizing the FlexLM floating licenses that you have, or how often you're maxing those out, or things like that. License statistics by X formation can track that over time, and you can go back and get reports and really try to optimize your license usage. Solid Thinking, we often do webinars on their product for lightweighting design. So you can go in and put your loads and constraints on the model, and it'll remove any of the material that's not contributing to the strength of the part, so you can get as light a weight design as possible. We also have solutions for other high-end CFD analysis, mold flowing simulations, rendering, things like that. If you have any additional questions after the webinar, you can reach out to me at wmorvek@boundarysys.com, or if you have questions about pricing and packaging, you can reach out to our sales team at sales@boundarysys.com. We also have additional information on mechanism design on our website. And I'll put this information back up again at the end of the webinar. All right. So diving into the fun stuff here, we're going to take a look at how to create product videos in Creo Parametric today. And we're going to look at a couple of different tools that you can use to create animations and videos from Creo Parametric, depending on what you're trying to accomplish. And so the one that I think more people are probably familiar with is Mechanism Design Extension. That does come with every base seat of Creo at this point. Design Animation does as well, I believe. And Mechanism Design builds the animation and the motion within the assembly based on assembly connections and motors to drive a specific motion. And the idea is that you're sort of viewing the functional motion of the assembly. So you're building a mechanism and you're showing it move through its actual range of motion, how it would be used. With Mechanism Design, we can also provide additional information, so we can put measures on specific locations and look at how the velocity and acceleration and position of different components or points is varying over the analysis of that mechanism. So it's useful for seeing the actual motion of an assembly. It's also useful for doing some additional sort of analysis of that motion. And then if you just want a nice, pretty animation of the assembly as it's moving, you can render those. So you can use the photo rendering option to go in and define what materials everything's made of and your lighting, and then you can get a really nice photorealistic video of that assembly through its range of motion. Design animation, I think fewer people are aware of, but it's based, the animation there is going to be based on a key frame sequence. And so you basically can position your assembly or your components the way you want them to appear at different points, and then it will animate between those keyframes. It gives you more flexibility in terms of really building a specific video to show exactly what you want to, not limited to the motion of the actual assembly. And so that can be useful for showing the functional motion of the assembly in specific ways, but also building assembly instructions, showing how parts go together, showing how things would need to be disassembled to replace a component. Things like that can be built using design animation. And just like mechanism design, once you've constructed that animation in Creo, you can then render it as you're creating the actual video. So I'm going to show you an actual demonstration of sort of how to set up and create a video in both mechanism design and design animation. Before I dive into that, I do have an additional poll. So the question this time is, what mechanism design functionality have you used in Creo? Have you never used it? Have you assembled a mechanism assembly using connections, but not actually gone into mechanism mode to analyze it? Have you built and analyzed, or you're not sure, and that's why you're here? You'd like me to actually show you. All right. Most everyone has voted, so I'll go ahead and share the results. So you can see that the results are pretty well split between you have no mechanism experience, or you've assembled using connections, but you haven't actually used MDX mode to sort of analyze the motion of the assembly. A few of you have built mechanisms and analyzed in MDX. So again, we're going to show you a little bit of the whole thing. We'll show you how to put the assembly together with connections, and then we'll also show you how to take that into mechanism mode and sort of analyze it and build a video. We're not going to get into a ton of detail. There's a lot of depth for mechanism design. If you do have additional questions, feel free to reach out following the webinar, but we'll at least give you a taste of all of it in this presentation. All right. So let me jump into Creo here. And so at this point, I just have this engine assembly, and right now I just have sort of the static components in here. I need to go in and add all of the moving components into this. And so I'm going to hide the cylinder initially so I can see what I'm doing a little better. And I'm going to start out assembling my crank assembly. And so in order to build a mechanism or an assembly that's going to allow motion between the components, instead of assembling just using my standard constraints to assemble everything, I'm going to define connections. And so each connection allows a specific degree of freedom or multiple degrees of freedom. So a pin connection is going to allow one rotational degree of freedom. And so I need to, for that pin connection, I need to define an axis alignment that's going to define the axis we're going to rotate around, and then a translation constraint that's going to define the position along that axis. So axis alignment, I can just do cylindrical surfaces here. And so now you can see it's able to translate and rotate. So I want to remove that translation, and so I'm just going to pick my assembly front datum plane in that crank assembly, and the assembly front datum plane in my top level assembly. And now I just have the one rotational degree of freedom remaining. So I'm going to complete that. The next thing I want to place in here is going to be my my connecting rod. And again, I want to pin this connecting rod onto the crankshaft. And so I'm going to define a pin constraint or connection, define the axis, and for my translation reference, again, I'm going to pick the front datum planes. And then I need to show my cylinder. The next component I'm going to place in here is going to be my piston assembly. And the first constraint here is I'm going to constrain the piston into the cylinder, and I'm going to do that with a cylinder connection. So that's going to allow translation and rotation around the same axis. Select that surface. So now you can see that piston can translate up and down. It can also rotate. I'm going to hide my cylinder again. And so now I need to connect the piston to the connecting rod. And to do that, I'm going to go into my placement tab and I'm going to add a new set. So in this case, the piston is connected to the cylinder with that cylinder connection. It's also going to be connected to the connecting rod, also with a cylinder connection. There we go. And now if I want to test out the motion here, I can go in and I can just drag those components and see how everything moves. And so that sort of gets us to sort of that first level of using the mechanism in Creo is, instead of just using rigid constraints to put the assembly together, you can use these connections, and you can always just go in and drag things and make sure they're moving correctly. To take it to the next level, what I can do is I can go in, go to Applications, and choose Mechanism. And so if I go into Mechanism mode, now that's going to give me a whole new set of tools that I can use to drive a specific motion within the assembly and sort of see how everything is going to move relative to that. And so you can see all of those connections that I use to assemble things are showing up with these sort of orange arrows to indicate what connection and what motion is allowed within that connection. And so what I can do is I can create a servo motor that's going to drive a specific motion. So I'm going to click servo motor. I'm going to pick the rotational axis of the crank. So I put that pin connection on the crank, and then I can tell it that I want to drive the angular velocity, and I'm going to tell it that it's just going to be a constant, or I can have a bunch of different profiles to drive that. I'm just going to rotate 90 degrees per second. And so now you can see I end up with this little symbol to indicate that I have a servo motor that's going to drive the motion of that rotational axis. And I can put multiple motors on there. We have additional tools that we can use here. Some of these things like force motors, anything that has to do with forces, that's a part of the Mechanism Dynamics option. So Mechanism Design just allows you to see motion and simulate kinematics, sort of motion without respect to forces. That's all included in a base seat of Creo. If you want to look at forces and what are the reaction forces between components where they're connected, what type of motion are you going to get if you apply a certain force to something, then that requires going up to the Mechanism Design option, which is an add-on. So I want to go in and actually run a specific analysis to run this through its range of motion. And so one thing I can do is, if I always want this to start in a specific position, I can go in and I can take a snapshot. So I can take a snapshot, I can call that demo. And so now I can jump between different positions. So here I've pulled a couple of the bolts off of there. If I go back to demo, if I drag this to another position, that snapshot always allows me to jump back to a specific position. So I can use that when I set up my analysis as the starting point to run through the motion to make sure I'm always starting from a known location. So I have everything set up. So the next thing I want to do is I want to define a measure that's going to give me some additional information about this as I run it. So if I click measure, I can go in and create a new measure. And I'm just going to look at the translation of that piston. So that's going to be the translation of that piston. I'm going to look at, I'm going to call it piston velocity. I'm going to look at the velocity at each time step. And so it's going to basically measure and track that as I run the analysis. And that's the next step, is I want to go in and I want to set up an analysis that says, run this mechanism through its motion based on, everything that I've set up. So I'm going to create a mechanism analysis. I'm going to call this demo. I'm going to go in and set it to kinematic. So dynamic, static, and force balance, that all comes into, starts to take forces into account. So those come with Mechanism Dynamics. Position and kinematic come with Mechanism Design. I'm going to run from 0 to 8 seconds, 10 frames per second, and my starting position is going to be that demo snapshot that I set up. Under motors, I can see a list of any servo motors that I've set up and tell it what time frame to run over. So in this case, I just have the one motor. It's going to run the entire time. If I had a more complex assembly that has different pieces of it that can move at different times, I can have different servo motors set up to drive that different motion. I'm going to hit OK, and then I'm just going to run that analysis. So when I run it, I can see the motion that I'm going to get as it runs through there. Now that ran pretty quickly. I couldn't see it very clearly. So once I've run that, I can then go to playback, and I can play back through that motion. And I can adjust the speed. Now when I play it, it's going to run through there. If I turn the speed up, then I'll see it run faster. And so that's great just for going in. I can still rotate this. I can look at things while I'm doing this in more detail. So I can rotate it around, play the animation over here, but I still have to be in Creo at this point to actually see this animation. So if I want to be able to utilize this outside of Creo, what I can do is I can use the capture option here. And this is going to allow me to capture this as a movie file. And so I can adjust what is the image size going to be. So I'm going to leave this small, and I'll just do one real quick here. I can save it as an MPEG file or an AVI file, or I can just save the current frame as an image file of several types. So I'll save it as an MPEG, hit OK. And it's just going to step through that entire analysis. And if I go look at, yep, here's my engine new MPEG file that I can pull up. You can see I've just got a little video that I can go in and play back. Now, one of the other options when I did that capture was to photo render the frames. And so let me close out of here real quick. And go in here. And so here is basically the same assembly setup, but I have assigned colors to, or different materials and finishes to my different components through my appearances. And so I haven't done the piston yet, so I'm just going to go in and assign an appearance to the piston and to the piston pin. Once I've done that, now if I go to Applications, Render Studio, now I'm able to actually see a rendered image of that. So I've applied, basically different types of metallic finishes to the different components within the assembly. Let me turn off my rendering. And so now if I go into Mechanism and I play through the animation and I capture it using rendering, I can see, let me go to playback. Nope. I don't have a result set yet. So I can run through that. And then if I go to playback and capture, I can adjust my image size. So if I want to make this larger, I can also tell it to photo render the frames. And it takes a little longer to do that. It's actually not too bad for this one. But I can just pull up here. If I view that now, there we go. There's the animation. So it's got everything rendered and it's playing through that motion. And it's pretty easy to do that. Again, you just have to go in, you have to assign the appearances to everything, and then you just have to wait for it to render when you save the MPEG file. One other thing that I was going to show you here, let me close my other assembly. Back in mechanism mode, I set up that measure to measure the velocity of the piston. So just to show you real quickly how that can be used, if I go to measures, here's my piston velocity that we set up. I have to run my... So I can show my piston velocity with my demo results set, and I can just graph that. And so now you can see here's a graph of my piston velocity over time as we ran that. If I hover over any of the data points, it's going to show me what time that occurred at and what was the value of the measure. So here we're 21.7 millimeters per second up here. Right here, we're right around 0 millimeters per second. So that's where it's getting to the top or bottom of the stroke. The other thing I can do, and let me create a style rep here. So I can see a little more clearly. But when I go back and I play back those results, I have the option to display arrows in that playback. And so now I can see that arrow that's getting scaled according to the velocity of the piston. And I can also include that in the capture. So again, if you want to sort of visualize what are positions or velocities or accelerations, how are those varying throughout that run, you can include those as arrows, and you can capture that in your animated video as well. And then if you're using Mechanism Dynamics option, you can actually have those for like reaction forces and things like that. So you can sort of see what direction and magnitude the forces between components are taking. All right. So again, there's a lot more different types of motors and connections and things that you can use in Mechanism Dynamics, but that's sort of the idea. We're building an assembly, we're putting it together the way it's actually going to be assembled to allow this motion. We're putting certain drivers on those in the form of servo motors, and then we're animating the result of that, and we can capture that as a video. The other option that we have, close out of here, again, is the mechanism or the design animation option, where instead of looking at the motion of the assembly specifically, we may want to look at creating an animation of how an assembly goes together, or how to disassemble something to replace a specific component or something like that. And so before I dive into that part of the demo, I have another quick poll that I'm going to pull up. And so this time the question is, have you ever used design animation in Creo? The options yes, no, you've tried but couldn't figure it out, or you didn't even know it existed until now. All right, we'll go ahead and close that poll. All right, so it looks like about half of you have not used it, and a good portion of the rest of you have either used it or tried but couldn't figure it out. And it is a lot different than a lot of other things that you do in Creo. So it's not real intuitive. There's not a ton of material out there on it. So that's what we're going to show you here, is sort of how that's actually used. So I'm going to keep working on this engine assembly. And I'm going to turn my cylinder back on for now. And I'm going to go to Applications, Animation. and I'm going to go full screen. And one of the key things with animation, and I already have a bit of an animation set up here, is at the top you can see what we call the keyframe sequence. And so we're basically defining what everything looks like at specific points in time, and then it's going to animate between those keyframes. And so if I manage my keyframe sequence, this keyframe sequence is built on exploded views. And so this is an explode animation. So I just have a bunch of different explode views that I went in and set up, went to position, I dragged my components to the right spot, and then I just told it which explode view to show at different times. And that's the basis of my keyframe sequence. So it's basically taking everything, starting unexploded, and then gradually sort of showing how things are going to get put together. And so that is, if I close out of there, that's the red keyframe sequence on the bottom. And if I click on one of those, I can jump to how everything looks at that position. I can rotate it around. Now the other thing that I've done here, and I'll jump out of full screen for a second, is that I told it to use specific views at particular times. And so I can go in and just tell it a particular view orientation that I want to use, like my default view, and then I can tell it what time I want that to occur at. And that time can be based off of the start of the animation, or it can be based off of any of the key frames. So for example, if I close this, if I pick this one right here, that bolt 02 view is set to come in at 0.5 seconds after this explode 3 view. So you can see this is after that. And so what that does is if I drag things around to change the timing, if I move this one key frame sequence, that orientation is going to move with it. And so I can build parent-child relationships into my animation in this way, so that if I move one critical point, other things that are sort of tied to that. I need it to be in a specific orientation to show this bolt going in. It's not gonna throw that off. So if I just play this, there's what it looks like. And if I go to playback, I can slow that down. So you can see it animated from one view to another, and as it animates between those different explode states, it shows the parts sort of all going together. So again, that one was created using explode views. I can also create an animation using snapshots. And so remember when I set up my animation or my mechanism analysis, I told it to always start at that initial position snapshot. And so if I go look, let's save. If I go look at that drag components option, I already have several different snapshots set up here that are, I already created these ahead of time. These are the different positions that I want to animate between. So I've got those set up as snapshots. I also set this similar things up as exploded views, just to show two different ways of doing this. So the one that we looked at first, that was based off of exploded views. I'm going to do explode. For this next animation that I'm going to set up, I'm going to do it using the snapshots. So I'm going to create a new animation using snapshots, and we'll call this demo. And you can see that that got added to my animation tree over on the left-hand side of the screen. So one of the nice things that with design animation is I can set up multiple different animations. If I want one animation that's showing the motion of my assembly, and I want to do specific things with it, so I want to do it in design animation instead of just mechanism design, I can do that. Then I can have a separate animation that's showing sort of how things are going to be put together, those types of things. So the first thing I'm going to define in my animation is the keyframe sequence. And so in my keyframe sequence, you can see in this case, I'm selecting from those snapshots because I told it I'm doing a snapshot animation. And so I created these in one order. I'm just going to animate it in the reverse order to start sort of fully pulled apart and then animate things going together. So I'm going to start at snapshot 0 at time, or snapshot 7 at time 0, and just select these. Snapshot 6 at time 1, 5 at time 2, and finish at the initial position. And so you can see that added my keyframe sequence in here. We'll go full screen again so we can see it a little better. And so if I play that, you can see it's showing how everything goes together, but it's not orienting things so that I can see it clearly. So I still need to go back and add in those orientations at different times. So I'm going to tell it to do view at a specific time. And we're going to start with my cylinder view at the start. Then I want to orient to my bolt 2 view, which is zoomed in a little bit. And that's going to be at snapshot 5. So now if I play that, you can see it starts zoomed out and then it zooms in as it puts those first couple of components on so that I'm zoomed in by the time I get to that bolt. When we get over to, once it puts that bolt in, before it starts moving this other bolt, we need to have, basically need to rotate it around so that I can see what's going on the other side. So basically in between here and here, I need some, I don't think that's actually doing anything. So I'm going to edit my keyframe sequence. Maybe it is. Okay. So I'm going to add another view at a specific time. This is going to be bolt 1. Right there. Now, if I just play that and sort of take a look at what that's doing, you can see that actually started animating to that bolt 1 view too soon. And so what I really want to do is we're going to put some extra time in here. I can just drag things around in my timeline to adjust that. And I want to add another view in here. We're going to stay at the bolt 2 view, which is where we are over here. We're going to go to snapshot 4 plus 0.5 seconds. So there's bolt 2. It's going to stay at bolt 2 until here. And then this one, we're actually going to adjust that a little bit. And so again, I've based those times off of these frames. So if I move when that keyframe occurs, it's going to change when that orientation change needs to complete. So if I go back and play this again, if I play that back, be able to see It puts that bolt over. Now it's still starting to rotate before that bolt went completely down. So I may want to go back and adjust, I think, where this is occurring. I think maybe this one. I'm missing a frame. So I can just drag that and sort of adjust when that next rotation occurs. Now the next thing I want to do, so we've got sort of how everything fits together working pretty well. Because I'm using my snapshots, I also have access to some of my mechanism functionality. So I actually can go in once we get to this position, and I can tell it to animate with a servo motor. And so I can tell it to manage servo motors. I can tell it and include. So I can include that servo motor. So I set it up, it's already defined, it's got the angular velocity defined. When I include it, it just adds it to my keyframe sequence. And so now I can come in and basically tell it, okay, when it gets to the end of my my assembly, then run through the range of motion. And so I'm going to go back and play it. And that's what we end up with. Now I didn't rotate it very much because I just had 2 seconds here. I could go to time domain and I could extend that time, or I could go to that servo motor and I can adjust my angular velocity. So we were just doing 90 degrees per second. I'm going to do 360. So that way it's going to do 2 full revolutions in those last 2 seconds. The other thing I want to do is I can't see that motion very well because my components are all solid. I can't see the piston moving up and down inside of there. So I may also want to make some of these components go transparent when I get to this point in the animation. And so to do that, I'm going to add something in here. I'm going to add a couple of events. So what is an event? It's just a point in time that I can keep track of, and I can tie other things to. So this is going to be called end of assembly. And it's going to occur at that initial position keyframe. And so now if I move when the end occurs, that end of assembly is going to adjust. Then I'm going to have an event called start of mechanism. And that's going to be at 1 second after end of assembly. And so now I'm going to take that engine run, and I'm actually going to change my time domain. We're going to run for an extra second. So my time domain, instead of running for 10 seconds, this animation is going to be 11 seconds long. So it gives me a little extra time to work with. And when I adjust that servo motor, I'm going to tell it's going to start the servo motor at start of mechanism, and it's going to end at the end of demo. And so now if I change where the last assembly step ends, it's going to move the end of assembly, start a mechanism, and engine. You can see how everything's tied together with the little lines there. But now this is sort of tied together so that if I move one thing, other things can move with it. And so what I'm going to do is I'm also going to tell it between when it finishes putting everything together and it starts the motion, I'm going to go in and define some transparencies at times. So I'm going to select these three components, and I'm going to tell it that at end of assembly, those are completely opaque. And then those same three components at start of mechanism are going to be fairly clear. Get rid of those edges because that's going to complicate things. All right, so again, just added some additional layers on here. So we're going to add some transparencies and then we're going to run the motion. So let's play through that now, see how everything looks. And if I go to playback, now I can adjust my speed. There we go. And anything else that I want to sort of add into that animation, I do in that same way. It's just a matter of like continuing to add additional sort of layers onto this keyframe sequence and to this timeline. For example, if I want it to go back to a different orientation before it starts that animation, I could do the same thing. So I could go in and tell it I want don't save animation. So I can go back in and I can tell it, okay, I also want my view to be still bolt 1 at the end of the assembly. And then I want to go to just my default orientation. Nope. Go back to that bolt 2 orientation for the beginning of the start of the mechanism. And so now we're not only going to add the transparency in that gap where nothing's moving, we're also going to rotate the assembly back around to a view that's going to show the motion a little bit better. So again, I can go back and play that. And once I've done that, then if I go to playback, I can play that back. There we go. And then if I hit save here, from the top of my timeline, that's going to bring up the exact same capture page that we saw in Mechanism. So again, I can adjust what my resolution or my image size is going to be. I have the option to photo render the frames if I want. And then when I hit OK, it's going to go out and it's going to save that animation. I'm not going to animate those frames. See, it's just going through there and it's creating that movie file in the background. So that's design animation. Again, you make the choice up front. Are you starting with exploded views to define those keyframes or snapshots? It depends how much mechanism is going to be involved, which of those you're going to use. And then set up the keyframe sequence, and then you just layer on all of the additional details. For example, all of my components when I started that, if I go back to the beginning, all of these bolts and extra components, and everything is transparent because I never turned my transparency off. All the bolts and extra components and everything that I put together, all start out visible. If I wanted those to be hidden, I can go in and use my my style or transparency at a time to blank those items and just show this component's going on. Then show some of those components that were hidden, show them come together, and just keep adding on those different layers. But it's just sort of that iterative process. Build out a little bit of the animation, see how it looks, add the additional details, orientations, transparencies, anything like that that you need until it looks the way you want. So what I really need to do to make sure I don't have that extra transparency is I just need to go back and set my transparency at time for these three components at the start to be opaque. Oh, I already defined that. Yeah, so now nothing becomes transparent until I explicitly told it to add that transparency at the end. So that's design animation. Again, which of these tools you want to use, mechanism design or design animation, just depends on what you're trying to do. If you're just trying to show the motion of the actual assembly based on specific drivers, and then you need a movie of that, the mechanism design is going to work fine, and then you can do the capture. If you need to just put more polish on the animation itself, you want to control what angle everything rotates to at certain times, you want to hide components at different times, or you want to do anything beyond just the mechanism motion, then you would want to come into design animation to do those types of things. All right, so that's pretty much everything that I was hoping to show you during the presentation. I'm going to go ahead and open it up for questions now. So if you do have any questions, lots of questions over here. So let's see. Can a movie be made with the assembly in a cross section? Yes, I believe if you have applied a cross section, that you can set up the movie in that way, and it's going to capture it with that. So let me go confirm that real quick. Yeah, so let's say we create a section, simply right, and then go to mechanism. Yeah, so I would want to tweak that cross-section to make sure I'm not cross-sectioning the parts that are moving. But yeah, you can cross-section like the engine block components, and then you can show the motion of the other components within there. You can do that. One of the questions was how can the mechanism be saved with the Creo data on Windchill? The mechanism itself and the definition of the analysis and everything is part of the assembly definition. So that will get saved with the assembly model within Windchill. If you save like the playback results or things like that as a separate file, those I'm not sure how those get managed. They may be saved as attachments in Windchill to the CAD document. One of the questions was within the keyframe sequence menu, there's a checkbox to follow explode sequence. That one, I have not played around too much with that. I know there are certain explode views where you can sort of define the explode sequence sort of internal to the exploded view as you go in and modify the position. So I think it's possible, instead of having a separate exploded view for sort of every single keyframe in there, if you've defined an exploded view that has sort of a sequence in terms of how it should should animate the explosion of that, that you can just build that into the animation as sort of a single keyframe. It'll do that sort of internal explode animation on its own without having to sort of capture each of those as a separate explode state. That I hadn't done it that way. I just did each one as its own explode state, so I didn't necessarily need that to be turned on. One of the questions, this is actually a good one that I can show you an example of, was how to overcome constrained data on assembly which is created through Mechanism. And so let me go back and get rid of this cross-section view. Yeah, so let's say I wanted to create a snapshot where some snapshots so that I also want to show how the piston is going to go together. Well, I have this piston pin in here, or maybe I want to just show the piston pulling off of here. What I can do is I can go in to my constraints tab, and I have the option to disable my connection. So within my drag window here, as I define those snapshots, I could go in and disable that cylinder connection that's connecting the piston to the connecting rod. That constraint is now disabled, and so now when I go in and drag that, I can drag it independently of that. If that's turned on, it's not going to let me do that. It's going to drag, try to drag the whole assembly at that point. But if I disable that, now I can pull the assembly apart. So yeah, as you do this, you typically start with everything assembled. If you want to show how a mechanism is being assembled, you start with everything assembled, disable a connection, drag your component, create a snapshot, disable another connection, drag a component, create a snapshot. You sort of gradually pull it all apart, and then you define the keyframe sequence in the opposite order. One of the questions was, how can I get a replay of this in a video for reference? I'm recording the webinar, and in the next day or so, we should have it up on YouTube. And I believe we email that link out to all of the attendees. So yeah, by tomorrow or so, we should have a YouTube video where you can rewatch the webinar. One of the questions is, can you add notes on the screen for assembly details like the part number in an assembly video? There's not a real direct way to do that. You might be able to do it with notes for like model-based definition if you create notes or things like that. But in general, design animation, it's just for creating the animation. There's not really good ways to add that type of information on. If you want to have sort of a similar animation of how things go together, but with some visual notes of things like that, then the tools available in Creo Illustrate may be better for those types of things. One of the questions was, can you use a saved playback from Mechanism Design and use it in the animation application? Yes, you can do that. Let me show you how you would do that. So if I go to Applications, Animation, to do that, I need to create a new animation. And so there is a third type that I didn't talk about, which is called Import from MDO, where I can go grab that playback file. And so now the playback of that animation is the basis, and then I can layer on my view orientations and things like that on top of it. That is not going to allow me to define a keyframe sequence with exploded views or snapshots or anything like that. It's just taking that animation that's already created and then controlling orientation and styles and those types of things. So if you want sort of the combination of how do things sort of go together plus the animation from Mechanism, the best way to do that is with the keyframe off of snapshots and then adding the servo motors into it. Or you can have multiple animations, create each of those, and then use an actual video editor to just edit those together into a single one rather than trying to capture it all in a single animation in Creo. One of the questions was, is there an animation that might show interference points or surfaces? And so yeah, we want to check to see, okay, as we move through this range of motion, are we getting any interference in here? And yes, I can do that. If I go into mechanism mode and I go to playback, one of the options here is collision detection settings. And so the default is no collision detection because it's going to run the fastest. If I do global collision detection, it's going to search for interference between any of the components. I have the option to include quilts. I have the option to make a sound or to stop the animation upon collision. I'm going to leave those turned off. And once I have that turned on, now it's going to check for interference either when I run an actual mechanism analysis, but also just as I drag through the range of motions. Let's see, we're getting, looks like we're pretty good here. Let me go make a change real quick. Trying to think of what I can change to make this interfere. Oh, I know. Let me go to my piston. Get rid of that cutout down there. And now if I come back over to my engine, there we go. Now you can see it's highlighting in red where I'm getting interference between the piston and the crankshaft. So yeah, you can do interference checking in the mechanisms. You just have to make sure you turn that on in the collision detection settings. And then once that's on, again, when you're dragging components, when you're running an actual mechanism analysis, it'll search for interference in both of those cases. One of the questions is, how do you do translation or to translate rotation movement to linear, such as like a lead screw actuator? That's getting into more complicated connections. So you have to set up the root connections. The one would be, like if you have a rotational motion that's going to create a linear motion in another component, or gears or things like that. You put the pin connections and the slider connections in there, and then you can use gear connections to connect two different motion axes. So if I have two standard sort of sprocket gears that are going to rotate, I can tell it what is the gear ratio between two pin connections. And now when I rotate one pin, it's going to rotate the other pin according to it. Or I can do different types of gears so that it's can translate rotational motion into linear, again based on the selection of those motion axes and the gear properties that you define. One of the questions was, could animation work for features included in the assembly model tree, like a revolve or an extrude? No, the animation, it's all going to be for sort of the components within the assembly. So yeah, if you have any assembly level features, I don't, those are sort of seen as part of the assembly. The assembly itself is sort of the ground body. So if you have any features that are assembly features, those are going to stay static relative to the assembly itself. So yeah, pretty much if you want motion, those need to be separate components that can be positioned so that you can move them around within the frame of the assembly. I think that was all of the questions that I saw on there. See if anybody is still listening to me. Oh yeah, most of the crowd is still here. Yeah, so unless there's any other questions, if you do have any questions, again, you can add them into the question box or raise your hand to get my attention. But otherwise, thanks to everybody for joining me. If you think of additional questions later on, I'll put my contact information back up. Feel free to reach out to me with technical questions or to the sales team if you have questions about pricing or packaging or any of those types of things. So thanks, everyone. I'm going to go ahead and I have a question. Could I run that engine at a realistic speed, say 15,000 RPM? I certainly could. And I just have to adjust my my time frame and my frames per second so that I'm capturing realistic information. So it's just a matter of, I ran it at a quarter of a rotation per second initially, which isn't very realistic. And then I ran the analysis for 2 seconds. If I'm running it at a very high speed, I'm just going to have the time of the analysis much shorter and many more frames per second, which I could do, but I'm not going to because we are out of time. So thanks again to everybody for joining me. Like I said, if you have any questions, feel free to reach out afterwards, and have a great rest of the day.